Welcome to mathclicks.com, powers of 1/2 and -1. This is a continuation of our powers of 0 and 1, which we'll be using here to help explain the fractional power and the negative power. So right off the bat, let's start off with our negative exponent here. Now, any base raised to a -1 will be just the fraction of that base, 1/3. Why is that? Why is 3 to the -1 1/3? Well, we remember that we got to 3 to the 0 power equaling 1 by doing a subtraction of exponents. So let's break this 3 to the -1 down into 3 to the 0 minus 1, which would look like this in fraction form, being that it's divided by the power on the bottom coming from the subtraction. Well, we can also break down that 3 to the 0 as 3 to the 1 minus 1 minus 1 equaling 3 to the 1 over 3 to the 1 all over 3 to the 1. This simplifying out to 1 and this simply simplifying out to 3 equaling 1/3. So that is why a negative exponent of 1 equals just a fraction of that. Now, it also holds for other negative exponents too, meaning that 3 to the -2 is going to be 1/3 squared. Similarly, coming from 3 to the 0 minus 2 equals 3 to the 1 minus 1 minus 2. Looking like this: 3 to the 1 over 3 to the 1 over 3 to the 2. So it holds for any magnitude of that exponent, flips it into a fraction with the magnitude as the power on the base, now in the denominator. So, on to fractional powers. How do we get fractional powers? Well, we know that 9 squared equals 81. It's showing in the last video that 9 could also be written as 3 squared. Well, if we square that again, that equals 81. So, a base with an exponent raised to another exponent, we really just multiply these exponents and we get 3 to the 4th, which equals 81. So what does that have to do with fractional powers? Well, we're really just distributing this fractional power among different bases. Well, we know that square root of 3 times the square root of 3 equals just 3. Well, since it's a square root, we like to use a 1/2 to indicate that it's coming from a square and not from a cube, or else we would use 1/3. So this is really 3 to the 1/2 times 3 to the 1/2, which equals 3 to 1/2 plus 1/2, which equals 3 to the 1. So that's why when we multiply two radicals of the same base together, we just drop the radical and keep the base. Because really, we have a fractional 1/2 plus a fractional 1/2 equaling a 1. This can also be illustrated with cube roots going from the cube to the root. So 27 equals 3 times 3 times 3, or 3 cubed. So if we started off trying to find the cube root of 27, we can rewrite that as 27 to the 1/3, which can be rewritten as 3 times 3 times 3 to the 1/3. And now we multiply out, and since there's no addition in here, we can distribute this 1/3 to each of the bases that are within there multiplied by each other. So this equals 3 to the 1/3 times 3 to the 1/3 times 3 to the 1/3. And because of the addition principle, this is 1/3 plus 1/3 plus 1/3 equaling 1 plus 1 is 3. 3 over 3 is 1. 3 to the first power equaling 3. And that is why any base raised to a negative exponent is its fraction, and any base raised to a fractional exponent is the same magnitude root of that base. Now let's do a little crazy thing here and just make a real complex one. Can you guess, and pause the video, see if you can do this on your own, 9 to the negative 1/2 power? All done? All right. Well, we know to flip this into a fraction of 1 over 9 to the 1/2, which is really 1 over the square root of 9, which is 1/3. All right. You got it. Thanks for watching and have a great day.